Alright guys, so I have another treat for you guys today. This time we're going to do some testing between standard car audio RCA cables and how they pick up noise versus professional audio XLR or a differential circuit. So in case you're not aware, you can find a lot of info on this on basically the internet. Single-ended is basically RCA. The outer shielding of the cable carries a ground, and then the inner one is the one that actually carries the AC wave up and down. So when there's external EMI, electromagnetic interference, and other sort of noise radiation, the problem is that because these grounds are tied on the devices across the chassis, the noise only enters the middle pin. So that can actually create all kinds of distortion. And we could actually see that in my current setup right here. And I'll do a full video if you keep watching. I'm going to take this simple screwdriver here, or this drill. I'm going to run it by the RCA cable. And the motor itself creates electromagnetic radiation, and that's picked up by the device as it flows into the RCA cable. And of course, when you have speaker and power lines and whatnot, it's actually much worse than that. But what I'm going to do is, using these ends, I'm going to create a custom connection to this XLR cable. And we're going to do the same testing using the differential circuit my Quantasylum already has built in. So we're going to see whether or not we truly have better noise cancellation with XLR, and what we might be able to do about it in car audio for most car audio amplifiers, which use RCA or don't use balanced differential circuits or don't use digital toslink connections. All right, so I took my donor XLR cables, I took the ends off, and all I did was connect the cable itself to these dual-ended RCA ends, again, so I could connect them to my differential circuit. I'm just going to cover this up with some tape, but you can see it's basically a copper shield which carries the ground, and then two internal conductors. And what's really important about XLR is that these are twisted together, usually in the middle. That way, when the noise, the EMI noise interferes with them, it does so equally, both to the positive and the negative. That's very important because a differential circuit basically measures the difference between the two ends. And if they're both affected in one direction, so positive or negative, the difference stays the same. All right, so I now have my differential circuit connected on my left channel and my normal RCA on the right channel. So we can already see something interesting, which is that on the left, where we have the differential, again, this is literally nothing but just a signal flowing through input to output. We can already read a much cleaner signal, right? And we could see THD is negative 116 versus 114, and SNR is negative 112, or 112 versus 110. So we already have a cleaner signal because of the type of circuitry involved in being able to read that. So all I'm going to do now is I'm going to take these two cables, which is the standard RCA and the differential. I'll put them close together. I'm going to run different types of devices near them that create EMI. In this case, I'll have a little drill. I'll have a high-speed motor from a little fan, and I'll also use a little vacuum. So they should create all kinds of noise, and what we want to do is look at the difference in noise being picked up. Again, differential will be blue, RCA will be red, and our goal is to see whether or not differential really does reduce noise. Take this into account. This might be really interesting if you have a head unit pushing out RCA all the way at the front of the car, and then you have a long cable run, 10, 15, 20 feet, going to the rear of the car where your amplifiers are. That cable may snake all over the car on top of power wires that have transients, on top of, different type of CAN bus, high frequency signal generators and so on. So let's see what happens, whether or not we can actually reduce noise with the differential circuit. So notice we literally had no movement on the differential side and all of the noise was picked up by the single-ended unbalanced cable. Literally, there was absolutely no difference on the blue, which is this cable, versus RCA, which is red. All right, let's now use a little nastier device. This one should have a little bit more power, should create some more noise. All right, finally, we're going to use the bad boy. All right, notice that one creates so much noise, slight leakage into the differential, but we're talking about how many orders of magnitude here? 2 orders of magnitude more high frequency noise it's making its way into our unbalanced circuit. Look at that THD, the SNR, keep an eye on these numbers. And then of course the chart which shows the signal. This is what we want. Everything else needs to stay as low as possible. Anytime you see spikes, that's basically noise making its way into the circuit. So all of that high frequency noise from this motor, from 1 kilohertz up, we could even zoom in and you could see just how much of that noise is leaking through standard RCA versus the differential circuit. All right, hopefully I've made my case on the fact that RCA, single-ended, picks up noise, a lot more noise, versus differential, which is used in professional audio, home audio, etc., because you could see just how much noise it can reject. And that is really useful when you have long cable runs and there's more and more opportunities for noise to make it into the circuit. Now, what does this mean for you if you have a car audio product and you don't have differential circuitry available inside of your amplifier, inside of your head unit? You can't run digital and you must only run RCA. Well, stay tuned because I've been working on a device